Hi guys, and welcome to another video. And in this particular video, we're going to be looking at grade 12 maths algebra, challenging questions from past year papers from 2010 to 2019 part 2. The question that we're going to be looking at today is from the November 2018 exam paper. It reads as follows: question 1.3. If 3 to the 9x equals to 64 and 5 to the square root of p equals to 64, calculate without using a calculator the value of 3 to the x minus 1 equals to 3 all over the square root of 5 raised to the square root of p. In a question like this, here they are testing exponents, so therefore let us simplify as far as possible. So here 3 to the x minus 1 raised to the power 3, we're going to multiply out here this index with this power, so it will be 3x times 3 is 3x, and minus 1 times 3 is minus 3. And here we're left with the square root of 5 raised to the square root of p. So that's going to be 5 to the half times the square root of p. The rules that I used here are basically the following. If I have x to the m raised to the power n, it will be x to the m times n. The rule that I used here is if I have the nth root of x to the m is equal to x to the m divided by n. So therefore, remember now the square root of 5, square root of 5, remember there's a 1 there, there's a 2 there, square root, so therefore that's 5 to the half. These are important rules. Please revise your rules of exponents before you attempt questions of this nature. Now that we've opened out these particular brackets here, or we've simplified, now let's go look at what we were given. We're given 3 to the 9x equals to 64. But here we got 3 to the 3x. So therefore 3 to the 9x equals to 64. The question is, how can we get 3 to the 3x? Well, you need to now divide that by 3. So still using this particular rule, so that means if I take the cube root of both sides, now remember 64 is a perfect cube. If I take the cube root of both sides, so it will be 3 to the 9x equals to the cube root of 64. I'll be left with 9x divided by 3 according to this rule that I just discussed now. So it will be 3 to the 3x equals to the cube root of 64 is equal to 4. So now I've got 3 to the 3x is equal to 4. So now I've got this part sorted out, 3 to the 3x. Alright? Now let's look at 5 to the half times the square root of p. What else am I given? I'm given 5 to the square root of p equals to 64. Now the thing about 64 is that it's a perfect cube and also a perfect square. So learners, if I now look at 5 to the square root of p equals to 64, and if I take the square root of both sides, and I'm still going to be applying this rule here. So therefore now remember that I will have 5 to the half root p equals to the square root of 64 will equals to 8. So now I've got this bottom part sorted out. 5 to the half times root p equals to 8. Let's simplify a little bit further. So now I've got 3 to the 3x times 3 to the minus 3 all over 5 to the half root p will equals to 3 to the 3x is equal to 4. So I'll write 4. 3 to the minus 3. Remember this rule here. If I have x to the minus 1 equals to 1 over x. So I can now take that to the bottom. So it will become 3 cubed times 5 to the half times root p. We work that one out here. 5 to the half times root p is equal to 8. So let's substitute 8 here. Equals to, we can just put that in our calculator. 4 all over 3 cubed times 8 that's equal to 1 over 54. 1 over 54. And that's our solution, 1 over 54. This question appeared in the November 2018 paper 1. Let's look at the next one. The next question that I want to look at is from the November 2019 paper 1. Question 1.3 reads as follows. It says, consider the product 1 times 2 times 3 times 4 times 30. So it's all the natural numbers from 1 to 30 that are multiplied by each other. It says determine the largest value of k such that 3 to the k is a factor of this product. How can 3 to the k be a factor of this particular product? Well, what we have to do is we have to basically count all the 3's from 1 to 30. Now, in order for us to count all the 3's from 1 to 30 so we can get a value for k, we firstly need to look at all the multiples of 3 from 1 to 30. Let's write them down. What are the multiples of 3 from 1 to 30? So we'll start off with 3, 6, 9, 12, 18, 21, 24, 27, and 30. So 3, 6, 9, 12, I think I missed out one here, 15, 18, 21, 24, 27, and 30. So what do we have here? So remember 3 is 3 times 1. So let's just break it up a little bit. 6 is 3 times 2. 9 is 3 times 3. 12 is 3 times, so I'm writing it as a product of its prime factors. 3 times 4 is 3 times 2 squared. 15 will be 3 times 5. 18 will be 9 times 2, which is 3 squared times 2. 21 is 3 times 7. 24 will be 3 times 8, which is 3 times 2 cubed. And 27 will be 3 times 3 times 3, which is 3 cubed. And here we got 30, which will be 3 times 10. So we can write it as 3 times 2 times 5. Now the reason that I wrote it as a product of its prime factors is because I want us to make sure that we're able to count all the 3's from 1 to 30. Now remember that if we do that, we'll be able to solve this question. So let's count. So we've got 1, 2, 3, 4, 5, 6. So there's 2 here. So we'll say 7, 8, 9. And what do we have? 10. And there's 3 here. So that will be 11, 12, 13. And then there's 1 here, 14. So basically there are 14 3's that we've counted. Therefore my solution will be as follows. It will be 3 to the 14 equals to 3 to the k. Therefore we can conclude that k must equal to 14. And learners, that's my solution. K equals to 14. If you haven't subscribed already, subscribe to JL Maths. Also like my Facebook page, Justin Lazarus Mathematics. You can also watch all the videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.